Hello everyone. So in this video, I'm going to show you how to graph polynomial functions. So let's talk about the concepts such as what are zeros, end behavior, and multiplicity, because we're going to be using these ideas when we're graphing any given polynomial. So what are zeros? Well, zeros are pretty much your x-intercepts. Okay, so the way we're going to find zeros of a polynomial is by setting the function equal to 0, or you can think of setting y equal to 0. In the end behavior, I'll describe them as I go along. And multiplicity is just how many times is that particular 0 being repeated. Is it once, twice, 3 times, 4 times, and so on. And then we'll emphasize the multiplicity around the 0 as we graph the function. So take a look at our first example. So say we want to graph the polynomial p of x is equal to, say, x times x minus 3 and x plus 2. Now, first thing you want to do is always factor. This is already factor, so we don't need to worry about that. So let's go ahead and find the zeros. So the zeros for this polynomial is, so we set each factor is equal to 0, so we're going to set p of x to 0. So that would give us x equals to 0. And that's the first factor. Then we have x minus 3 is equal to 0, which will give us x equals 3. Then we take the second factor, set it equal to 0. X plus 2 is equal to 0, which will give us x equals negative 2. So the zeros for this given polynomial are x equals 0, x equals 3, and x equals negative 2. So these are the x-intercept for this given function. Now, what we're going to do, we're going to plot the zeros on our xy plane. So here is the xy plane. Let's plot them. So we have a negative 2. That's one of the intercept. 0 itself is an intercept, and 3 is an intercept. So let's suppose this is 3. So that's the zeros. Now let's talk about the end behavior. Well, end behavior just means what happens at the ends of the graph. Well, meaning what happened over here after 3 and what happened before negative 2. So you want to determine what happened at the two ends of the graph. So the graph can behave either go up in this direction or go down. And then at the negative 2 sides, it can also go down or go up. Now, how do we know which one to pick out of the 4 choices? Well, here's the thing. So we're going to look at the degree of this polynomial, meaning what's the highest power. So if you were to expand this polynomial, just the first terms, you don't need to expand all of them. So multiply this times that, so you get x cubed. So we have x cubed as the highest power of this polynomial, which means the graph going to behave like an x cubed function, which, if you remember, looks something like that. So the end behaviors are either going to be this way, or if the coefficient of the leading term is negative, then it's going to behave this way. So it's going to have these two end behaviors. Now, because ours is positive, we're going to look at the solid graph I just drew in green. So we're going to have plus infinity in this direction and minus infinity in this direction. So those are the end behaviors. So we get that by looking at the degree of the polynomial and the coefficient of it. So now that we have determined the end behaviors, now let's take a look at the multiplicity. Multiplicity just means how many times is that particular 0 is repeated. For example, x equals 0 came from this factor, which has a power 1. So it's only repeated once, meaning it's a linear factor. You can think of it that way. So that means when you go through that 0, you're going to make a straight line. You don't need to do any curve or anything weird. Now the second one, x equals 3, came from this factor, which has a power also 1. So again, create another line. So you're going to go through that 0 by making a line. And x equals -2 came from this one, which will also be degree 1. So you're just going to go through them. So, so we start with our end behavior from the left. We go through -2. So let's connect. We're going to go through them because that's what the multiplicity tells us. And then come to next 0, again, go through it. And then come to next 0, again, go through it and connect with the end behavior. Now I'm just going to make the end behaviors smooth because of what I drew earlier didn't come out to be smooth. But pretty much we have the graph down. So this is the graph of this polynomial. So really the end behavior together with multiplicity, you can draw any polynomials. Now there's also another way to graph these by making a table. So you can think of it as plotting these zeros on the real line. So if I plot them on the real line in order, so we have -2, 0, and 3. So this is the alternative way to graph. What you do is you pick a test value within each interval and you plug it into your P of x. So for example, I want to test interval -2 to 0. So I'll pick a test value, for instance, say -1. So we pick a test value to be -1. We plug it into P of x. So we want to evaluate P at -1. So we place -1 into the function P. So you have -1 times -1 minus 3 and -1 plus 2. So now you just want to know if the function value is positive or negative. We don't need to know the exact number. So we have -1, let's call it a negative real. -1 minus 3, that's another negative real. And then -1 plus 2, that's a positive real. So 2 negative reals times a positive, your result is positive. So in the interval -2 to 0, it's positive. Well, what does it mean to be positive? Positive means the graph lies above the x-axis. So, and that's exactly what we have here by using the multiplicity rule, that our graph is above the x-axis. Now you could go really high up here, or you can go like that. It's really up to you how far you want to go. Just make sure it's nice and smooth, not pointy. But pretty much that will be an alternative way to graph if you don't remember multiplicities. And then if you want to check the next interval, say from 0 to 3, you can pick another test value, something small, let's say 2, and then again plug it into P of x. And then from 3 to infinity, you can also test by plugging in 4, plug it into P, and so on. So pretty much that's the idea of graphing polynomial function. So that completes our graph for the first one. Now let's take a look at another example. So say we want to now graph this function. Say P of x is equal to -x cubed times x plus 2 squared and x minus 3. So we're going to find the zeros, describe the end behaviors, and then use the multiplicity to kind of shape out the graph nearby the zeros. So let's go ahead and find the zeros. So the zeros are, so if I set the first factor equal to 0, I get 0. If I set the second factor equal to 0, I get -2. And the last one will give us 3. So these are the zeros. Now, some of these zeros have multiplicity, meaning they're repeated more than once. So I'm going to circle the multiplicities. So 0 came from the first factor, which has a multiplicity 3. So I can say 0 has multiplicity 3. -2 came from the second factor, which is multiplicity 2. So this one has multiplicity 2. And 3, well, there is none, but we can say 1 is a multiplicity for 3. So this has multiplicity 1, sorry. Okay, so we're going to take care of that when we graph it. Now let's take a look at the end behavior. Well, we're going to use the degree and the leading coefficient to determine the degree. So the degree for this polynomial is going to be, so the first one has a power 3, and the second parenthesis is repeated twice. So that's like x plus 2 times x plus 2, meaning your leading term will be x squared. So that's 2. And then the third one is x to the 1. So we have a 3 plus 2 plus 1, which is 6. So the degree is 6, which has a similar graph to a parabola. Now, what about the leading coefficient of this? Well, that's a negative 1. So that's this right here. So what that means is the graph should behave like a parabola at the end. But if the leading coefficient is negative, then it's going to behave like a parabola facing downward. So these are the end behaviors. That's how the two ends should look like, facing downward. So either facing up if it's positive coefficient, it's negative, so we're going to be facing down. So now let's take a look at the graph on the xy plane. So we have the zeros, so we have negative 2, then we have 0 itself, and then 3. Okay. And then, so the end behaviors, so we know to the left of negative 2, it's going to go this way. To the right of 3, it's going to go this way. It's going to go down in both directions. Well, now we're going to use the multiplicity rule. So the first 0 is negative 2, which has a multiplicity of 2, which means it's going to create a nice parabola at 2. So we're going to create a parabola at 2, but we need to connect with the end behavior. So we're going to connect it, create a parabola, like that. And then to go from negative 2 to 0, well, we're just going to, and we need to see if 0 has a multiplicity. Yes, 0 has a multiplicity of 3, which means we have to go through 0 by making an x cube looking shape. Meaning if the multiplicity is 3, it's going to look like a cubic function. So we're going to come to that 0, but we're going to behave like cutting through, something like that, like a tiny x cube. And then 3 has a multiplicity of 1, which is a linear function. So it's just going to cut through it when it's connecting from previous 0. And that's pretty much how the graph looks like. Now I'm just going to straighten out this edge because it should be nice and smooth. So there you have it. So you see how we have to emphasize the zeros, and that's a good way to kind of come up with these pictures. And that's our function p of x. And of course, you can get to the same graph by, again, doing the testing. So you can pick a test value on the interval, say negative 2, 0, and 3. Pick any test value within the interval to figure out if the graph is above the x-axis or below the x-axis. But that's pretty much how we graph any polynomial. Now let's do another example, and this will be our last example. So suppose we want to graph the following. Say p of x is equal to x minus 1 cubed times x minus 2 times 2x plus 1. Okay, so again, we'll be finding the zeros first and then determine the end behavior by looking at the leading term, degree, and the coefficient. And then we'll look at the multiplicity to come up with the final sketch. So let's go ahead and find the zeros. So the zeros are, we're going to set the polynomial equal to 0. So if I set the first factor equal to 0, I get 1. And then second factor equal to 0, I get 2. Third factor equal to 0, I have minus 1/2. Now let's write down how many times are they repeated, meaning their multiplicity. 1 is coming from the first factor, which has a multiplicity of 3. So we can say 1 has multiplicity 3. 2 came from the second factor, which has multiplicity 1, since it's not written. So we can say this is multiplicity 1. And the last one also has a power 1 on the factor, which means this is also multiplicity 1. Okay, now let's look at the degree for this polynomial. So this polynomial let's see. So if I expand only the first terms, first one has a power 3, the second one has power 1, and the last one also power 1. So 3 plus 1 plus 1, that's 4 and 5. So the degree of this polynomial is 5. And the coefficient is going to be, well, we have 1 times 2, that's 2. So the leading coefficient is 2, meaning positive. So which means degree 5, it's an x cubic looking shape. So we know x cubed looks like this. And if it's negative coefficient, then it's a reflection. So it will look like that. But ours is a coefficient positive 2, so we're going to go with this one. So now let's draw it on our xy plane. So we have negative 1/2, 1, and 2. So those are the zeros. And then we do the end behaviors. So on the left end, we have negative infinity. And the right end, we have positive infinity. And now we're going to figure out in between by looking at the multiplicity. So we're going to start off with negative 1/2, which has a multiplicity of 1. So we're just going to cut through it and then go to next 0. So we're going to start from, so I'm just going to adjust my drawing because we need to make a smooth curve. So let's do that. So I'm just going to erase that and connect it with a different color. Okay, so we're going to cut through it. That's what multiplicity 1 means. And then go up, come back to 1. Well, 1 has a multiplicity of 3, which means it's going to create a cubic shape as it cuts through. So I'm just going to create the shape and then cut through. So let's try again. So here's how it's going to look like. Okay, so that's like a cubic shape. So it's going to cut through 1, but making a cubic shape because of the multiplicity 3. And 2 has a multiplicity of 1, which means it's just going to cut through, but not making any shape other than just linear line. So that's just a line. And that's the graph we're looking at. So I'm just going to cut that and smooth it out. So there you have the graph. Okay, so that's P of X. All right, so again, you can verify all of these shapes by making a table on a real line and just pick test values. Also, another really good point to find on this graph will be the y-intercept. So it will be very nice to label that point by setting x equal to 0. So if x is equal to 0, we have negative 1 minus 2 times 1, which would be positive 2. So this point is 0, 2. All right, so I hope the idea of drawing polynomial functions makes sense.